Some sounds are unwanted. These sounds are called noise collectively. White noise can be soothing if it's at the correct frequency, and that's really dependent upon the individual. That's why, for example, in the various testing centers on campus, the Student Access Center, the Dyslexia Center, they have those little white boxes that make the sound. In fact, we have like a little box like that in our bedroom. It just helps to mask out random noises and just offer a better environment. Hearing aids, many hearing aids will just amplify the sound at the same frequency. So for example, if you have a 400 hertz sound at a certain amplitude, then it'll make a 400 hertz sound at just a larger amplitude. But other hearing aids will actually modulate the frequency. That means that the hearing aid may not change the amplitude at all, that it might not actually amplify the sound, it just shifts the sound to a different frequency, because some people can hear just fine at one frequency, but not at others. Cochlear implants send an electrical signal to the brain via the auditory nerve. You may have seen a person with a cochlear implant. They often have like a little round disc on the back, on the part of their head right behind their ear, and it'll go into their brain or into their ear, and it takes those vibrations that it detects. It's like a microphone, and it translates those vibrations that it detects with its microphone into an electrical signal that goes directly to the auditory nerve. I'll have a video posted in the notes about cochlear implants. All right, so let's ultrasound imaging device is a handheld device that emits a very high frequency. High frequency on the order of 1 to 20 megahertz. So remember the human being can hear about 20 to 20,000 hertz. Well, this is a million to 20 million hertz. So much higher than you can hear. So it emits these high frequency sound waves, and some are reflected back. The device detects the reflected waves and it calculates the penetration depth. This is a lot like echolocation. I'll post a video about echolocation where it's sort of like what bats do, but this is also what a human does. And it's very much like echolocation. So imagine that this is a, a belly and there's a little person inside of it. There is a speaker that emits a high frequency wave, and then that high frequency wave is reflected back and it's detected by a microphone that's in this device. And it uses the information, that the time that it takes the wave to travel there and the time for it to travel back, to calculate distances to the features of the baby's face or the baby's arms or legs or whatever. So these ultrasound imaging devices can measure real-time motion. Including babies and blood flow. All right, let's remove this part. I'm sorry, that was just a mistake. One last thing about the resolution. So for the resolution of ultrasound imaging, it's about the same as the wavelength. So whatever the wavelength is of my wave, that's going to be the same resolution. So uh, when we talk about the resolution of these ultrasound imagers, for example, if I have a frequency of 3 megahertz and a speed of 1500 meters per second, which is approximately what the speed of sound is in those materials, like in the human body, then I know that the speed of a wave is equal to the frequency times the wavelength. So the wavelength would be the velocity divided by the frequency. And in this case, that would be about 0.0005 meters, or about a half a millimeter. That's equal to a half a millimeter. Not just for imaging, this can be used also to heat the tissue, and it's used in a restorative way sometimes. For restorative purposes, ablation of cancerous tissue means it breaks it up or kills it. Uh, and then the breaking up of kidney stones. Okay. Oh, one other thing up here. So I mentioned this. I can show this real-time motion of babies. It can also show blood flow, and you may have seen this before, where it shows the blood going in one direction and in another direction. It can discern between the direction of blood flow. Okay, that's the end for chapter 4.